Greetings students and scientists alike. Welcome to what I humbly call a solar flare seminar. Before we get started, I would highly recommend switching off your mobile phones, because after this video, you'll be looking into different methods of communication with your friends and family. With that out of the way, let's begin. So what exactly is a solar flare? Well, to put it simply, solar flares are sudden intense bursts of energy that vary in brightness. After being released from the sun, scientists begin to classify the solar flare by its own C, M or X class rank, in order to determine the level of impact it may have on Earth. Of course, do not worry about being sunburned due to the increased amount of heat. The Earth itself is surrounded by a magnetic field that filters out the majority of heat and radiation from the solar storm. Solar flares occur when the built-up magnetic energy within the solar atmosphere of the sun is released. This release causes immense amount of radiation to be emitted into space. This burst of radiation is made up of the entire electromagnetic spectrum, ranging from high frequency gamma rays to long wavelength radio waves. This release of energy has been recorded to be equivalent to millions of 100 megaton hydrogen bombs, all exploding at the same time. With all that energy in mind, how often does Earth experience this traumatic event? Well, according to NASA, once every 11 years, the sun experiences maximum levels of activity and releases solar flares into space. Of course, some solar flares do not directly hit Earth, but there have been a few in Earth's past history that have caused devastating effects to both satellite and communication devices alike. And as technology improves and integrates into humanity, solar flares have an increased ability to impact our everyday society immensely. So let's have a look at the biggest solar storms witnessed over the past 2 centuries. The first one on the list is the infamous Karaoglu event. Occurred in 1859, it was the first ever solar flare to be observed and documented. It was named after Richard Karaoglu, a scientist who witnessed a burst of white light whilst observing an active sunspot on the sun. According to NASA scientists, it was said to be the largest documented solar flare in the past 500 years. The flare itself caused severe interruptions globally. Auroras began to appear in countries near the equator. Telegraph communications blacked out. Offices that had cables overloaded and short-circuited, causing fires in main city areas. The flare was so big it was named as the Karaoglu super flare. NASA scientists estimate the solar flare to be an X10 class wave. This does put things into perspective about how well we as humans can survive against future super solar flares, considering our increased dependency on technology. The next one on the list is the Quebec blackout in 1989. According to NASA, this solar storm contained the equivalent amount of energy as a few thousand nuclear bombs exploding at the same time. This X15 class wave hit the Earth's magnetic field head-on and caused blackouts across Canada and northern United States, especially in cities like Quebec, which heavily depended on electricity for everyday life, thus being known as the Quebec blackout. The solar flare itself had melted many power transformers, causing power lines to short circuit. Despite not being big as the Karaoglu event, it still tested the durability of modern technology. Occurred in 2000, the Bastille event is the next one on our list. Named after a French holiday, this solar storm had registered as an X5 class wave. It was famous due to the major blackout of satellites and radio communications worldwide. Rated as an X5 class wave, it was special due to the immense amount of radiation exposure. The Bastille event had in fact showed the lack of durability of modern technology during that period of time. The next one on our list is the Halloween sunstorm during 2003. The sun had unleashed an intense sunstorm that had overwhelmed the spacecraft center that was measuring it. It was known as the ultra-powerful Halloween storm due to it being registered as an X45 class wave, according to NASA. It was not only a single wave, but in fact a chain of flares over a 2-week period. Known as one of the largest solar storms to be ever recorded, the solar flare had damaged satellites, disturbed phone and radio communications, and forced air traffic controllers to reroute flights, all due to the copious amounts of radiation emitted from the sunstorm. It served as a reminder of the vulnerability of modern technology during the beginning of the 21st century. And the final one on our list is the infamous Christmas solar storm back in 2006. This major X9 class wave occurred weeks before Christmas Eve and had in fact wiped out the GPS navigation signals for several hours. The solar flare itself had damaged the solar X-ray images on the GOES 13 satellite, according to the National Oceanic Atmospheric Administration officials. Luckily, Earth is a small target for solar activity, and despite disrupting communications, this solar storm was not entirely directed towards Earth. With the history of previous solar flares out of the way, let's have a look at the formation of solar storms and what actually allows it to have devastating effects on Earth. Step 1 of the process of creating solar flares is known as the precursor stage. This is when there is a large buildup of magnetic energy in a sunspot, which eventually short circuits to release solar flares along with emitting X-rays into space. Step 2 of the process is called the impulsive stage, where the protons, electrons and heavy nuclei are heated and accelerated to energies higher than 1 mega electron volt. By this point in time, radio waves, X-rays and gamma rays are emitted from the solar storm. By stage 3, the solar flare would extend out to the corona layer in the solar atmosphere, where highly rarefied gases heat up the solar flare, typically at 10 to 20 million degrees Kelvin, and sometimes even to 100 million degrees Kelvin. The corona is not uniformly bright, but is concentrated in areas of strong magnetic fields and sunspots. In other words, around active regions that form solar flares. Therefore, it only requires a grand total of 3 simple steps to create a cosmic disaster that could wipe out Earth's communication devices, leaving us in complete geographical isolation from one another. So what are the current monitoring programs for this cosmic disaster? Recently, Stanford Solar Center has developed an inexpensive space weather monitor usable by students. The monitors are built to detect any change in the Earth's ionosphere caused by disturbances such as solar flares. Students are able to simply collect data from the monitors on Stanford's centralized data repository, allowing them to discuss recent data about ionospheric disturbances. However, there are 2 versions of this monitor. One of them, known as SID, stands for Sudden Ionospheric Disturbance, which is designed to be used in high schools and for educational purposes. The other version, known as AWESOME, which stands for Atmospheric Weather Electromagnetic System for Observation Modeling and Education, is a more sensitive and expensive research instrument, typically made for universities for precise and accurate observations. These space monitors track the changes of the ionosphere in a very low frequency transmissions, otherwise known as VLF, as they bounce off the Earth's ionosphere. The VLF waves are transmitted around the Earth to detect changes on a global scale. These monitors then track these VLF transmissions in order to determine any changes in the ionosphere. Currently, there are websites like solarmonitor.org and spaceweatherlive.com that monitor any solar activity and update on a regular day-to-day basis. Of course, there are many articles online about minor solar flares. However, it becomes news once an X-class solar flare is released. When this occurs, NASA, along with other organizations, reveal images and information from satellites about any incoming super solar storms. Therefore, there is plenty of access to information about recent solar flares online. Whether it is simply constructing a mini space weather tracker at schools, or researching on constantly updating websites, the internet has provided us the ability to monitor and track any solar flare activity. However, what actually gets destroyed or damaged by a solar storm? What allows a solar flare to be so disruptive towards society? Well, since solar storms are composed of varying electromagnetic waves, once a flare hits a satellite, especially those in geosynchronous orbits, communications along with mobile signals are damaged. This damage is due to a high current that is discharged into the satellite, damaging a component and thus causing a blackout in communications. All the high energy particles are accelerated at high speeds that can actually penetrate and damage components as well. Along with that, the ultraviolet radiation released from the solar flare itself heats up the Earth's outer atmosphere, causing it to expand and increase the drag on satellites. This increased drag reduces the lifetime for the satellite in orbit, as well as delaying the communication signals and making the GPS measurements inaccurate. These energetic particles and currents not only affect satellites in the outer atmosphere, but as well as the Earth's magnetosphere as well. Once inside the magnetosphere, high currents are induced into power lines. This induction of current overrides and short circuits electric transformers and power stations, causing blackouts in large regions. The damage to our satellites and power grids may be extremely disruptive in today's society due to our dependence on modern technology. However, solar storms are not frequent enough to cause any permanent damage. With the danger of having a new world without technology due to the release of solar flares, humanity, along with their satellites and power grids, must endure the inevitable cosmic events to come. Despite the sun being the main source of hope for the growth on Earth, our solar system is a hazardous one, with danger lurking around every corner, ready to wipe out our technology within a single cosmic event and leave us in the darkness of a primitive world.